Now let's take a look at the third factor that we evaluate when we're ranking a series of acids or bases according to strength, and that is resonance effects. Let's compare acetic acid on the top in blue to ethanol on the bottom in pink. It's obvious from the pKa values that acetic acid is considerably more acidic than ethanol. And once again, we're left to answer why. It can't be due to elemental effects, as both compounds would yield a negatively charged oxygen if they were deprotonated. And there is some contribution of inductive effect from the second oxygen atom in the acetic acid. But that does not account for more than 9 units of difference between the two pKa's, so there's something else going on here. When acetic acid is deprotonated, the oxygen on the right is left hanging out with 3 lone pairs and a negative charge. However, you can draw a second resonance structure for this acetate ion and place that lone pair and a negative charge onto the other oxygen atom. And so if you were to draw the resonance hybrid, you would see that overall that negative charge, that added electron density, is really spread out over 2 oxygen atoms. And anytime that we can delocalize electron density over more atoms, that's a stabilizing effect. On the other hand, when ethanol loses a proton and forms ethoxide, the negative charge and the lone pairs are all located on the oxygen, and there is no resonance that can take place. So here's a look at the electron density maps of ethoxide and acetate. So note that the electron density is very localized over the ethoxide ion on the left, and it's delocalized over 2 oxygen atoms in the acetate ion on the right. So compared to ethoxide, acetate is a more stable anion, therefore a weaker base. And so acetic acid is more easily deprotonated than is ethanol. Therefore, acetic acid is a stronger acid than ethanol. Let's make another comparison. This time we will take a look at acetic acid on the top and methyl sulfonic acid on the bottom. Notice that methyl sulfonic acid is 10 to the 6 times stronger in acidity than acetic acid. Recall that we can draw 2 resonance structures for acetate, the conjugate base of acetic acid, shown here, but for methyl sulfonate, the conjugate base of methyl sulfonic acid, we can draw 3 resonance structures, and it's this extra resonance structure that accounts for the added stability of methyl sulfonate relative to acetate. The negative charge on acetate is delocalized over 2 oxygen centers, while in methyl sulfonate it can be delocalized over 3 oxygen centers. The result is that methyl sulfonic acid is a much stronger acid than acetic acid.